Let's discuss functions now. How do we use functions in R? Up until now, we've been creating simple objects by directing or directly assigning a single value to an object. It's very likely that you'll soon want to progress to create more complicated objects as you experience R more and more, and your experience grows more and more. And also the complexity of what we're doing is going to increase, especially once you start using it in your research and your work and so on. Happily, R has a multitude of functions to help you do exactly that. You can think of a function as an object. Again, everything in R is an object, which contains a series of instructions to perform a specific task. We've already seen one such function called the C function, the combine function, sometimes called concatenation. The first function we will learn about is C, open, close paren. The C function is short for combine or concatenate, and we use it to join together a series of values and store them in a data structure called a vector. Okay? This is what we've done before, and we'll show another example. I'm creating a variable or a vector, which is a series of numbers, and I'm using the combine function to combine these individual numbers into one variable or one vector. So in the code now, we've created an object called myVec and assigned it a value using the function C. Going back to R now, you can go back and create the myVector, evaluate that, and you will see that we have a new object, a vector called myVec, which is numeric and has 8 objects in the vectors, going from 1 to 8. There are a couple of really important points that we have to discuss here. First, when you use a function in R, the function name is always followed by a pair of round brackets, even if there's nothing contained between the brackets. Okay? Secondly, the arguments of functions are placed inside the round brackets and are separated by the commas. You can think of an argument as a way of customizing the use or behavior of a function. In the example that we've just seen, the arguments are the numbers we want to concatenate or combine. Finally, one of the tricky things when you start using R is to know which function to use for a particular task and how to use it. This is critical. Thankfully, each function will always have a help document associated with it and explain how the function works. And again, we've seen that Google is also a great resource to find information. So if I have a function such as C, I can Google C function in R and get some really good examples and documentation. To examine the value of a new object, we can simply type out the name of the object as we did before. So again, if I go and I print the myVec, I'm going to see the object and all the items inside the objects. Note that we've created a vector and we can use other functions to do so to create different vectors. For example, we can calculate the mean, variance, standard deviation, and number of elements in our vector by using the mean, var, sd, and length functions, which we'll learn in a bit. What are Boolean values? We keep hearing this kind of phrase, Boolean values. These are values that, as I said, could be true or false, or 0 or 1, or yes or no. They're all the same, and they're called logical variables. So true can be attributed or abbreviated to T, and false to F, and so on. And they allow us to use Boolean values in our vectors and analysis. The most basic object that we have is, as I said, a vector, and it can contain objects of the same class. So this is also very critical to know, that it cannot be mixed with numeric and character variables, items. It has to have objects that are the same class. But there is one exception called the list, which represents a vector that can contain many different classes. It's not going to be studied in this base course, but people taking the advanced course in the second semester will start using lists more and more. And as you can see, you don't have to only assign a vector individually, you can also combine two vectors. So let's look at this example. I can take the C vector that we've created before and the K vector that we've created in another step and create a new vector called K, which is K and the concatenation of 2 and 2.5. Let's look at some examples of creating vectors which are numeric. I can assign 1, 2, 3, 4, 5 items by combining into A and then print it. I can even go A plus 1, which will add 1 to every component of my vector. And obviously, as we've seen, I can do the mean and the variance of these vectors. So going back to R, this is an example of creating a vector named A, but also looking at adding the number 1 to each component of the vector. So if currently now the vector is 1, 2, 3, 4, 5, if I go A equals A plus 1, now when I evaluate A, you'll see that it starts from 2 and goes all the way to 6. You can also obviously assign character values to a vector. You're not limited just to storing numbers. You can also store strings as long as they're quoted within these quotes. And a string is specified, as we've mentioned quite a few times, by quotes. Both single and double quotes will work. So in a similar way, I can define A as hello. I can also define B as a vector of hello and there. Let's look at this example. We'll call B the combination of hello and there. And if I evaluate B, then you can see that this vector indeed has 2 items stored inside this vector. Now, you may wonder, am I stuck with a numeric variable forever? Or can I convert somehow a character variable to numeric? The quick answer is yes. There are functions in R that allow you to convert between the two types. If you take the function called as.character and run it on the A vector, which is a numeric vector, and create or assign it to a variable called race, you will see that the vector transitions from being a numeric variable to a character variable, and vice versa. If I take a vector that's numeric or character and add the as.numeric function to it, this will allow or result in a numeric vector. There is also something called explicit coercion, which is a nonsensical coercion results of a vector. So if I have a vector that is quite obvious character, and I try to coerce this, I try to run the as.numeric function on it, obviously this would result in missing data because R cannot force a character variable to become a numeric variable. Okay? Let's look at some examples. So I have a variable called A. I can evaluate that, and it's numeric. If I now convert the numeric variable into character and reevaluate the variable, I'm still going to see the same values, but as you notice, when obviously I need to evaluate race because I did an assignment. So if I assign something to a new vector called race, I obviously have to look at the values of race. And now you can see obviously that each individual component is quoted, and thus it's definitely a character variable. And if I look at race, I can get a confirmation on the fact that race indeed is a character variable. Okay. Remember, all elements must be the same time. So a vector has to be either numeric, a logical or Boolean vector, true or false, T or F, 0, 1, yes, no, a character variable, again, quoted, an integer, or additional types of vectors which we have not yet learned.